Okay, welcome everyone. This is the week one webinar. It's the first webinar that's really about statistics that we have, and the first of many. We'll have week 1 through week 11, actually. We don't do a webinar finals week because it's kind of over at that point. But so this is our first webinar. We're actually going to be doing statistics. Last night we had the webinar that was the orientation webinar. And just a note, it is important that best is if you can come live, but if you can't come live, it's mandatory to at least watch it. And that can be done on YouTube. And there's links to it from the module. There's also a link to it from the syllabus. From the syllabus, it's a link to the whole collection of videos. Right now, there's only one up on that, but in a few hours, there'll be two of them. So let me tell you the plan today for this webinar. I'm going to start out, and this is going to be true pretty much every webinar from now on, and that is Q&A. So if there's any questions, I'm always happy to answer questions. I'll do my best in answering at least. And good time to ask questions. And I want to remind you that if you have questions later on, you can ask then too, but I always like to start and also end with questions too. The end questions usually aren't recorded. Then after that, we're going to get into sampling techniques. And it turns out there's, a bunch of different ways of doing sampling, and some are better than others. None are perfect typically. And we'll talk about that. There's a perfect one, but usually you can't do the perfect one. And the better they are, the harder work it is. That's the other issue. So then we'll talk about, I know this is strange because that's the course's name is statistics, but I don't know if you ever thought about what does it mean to say statistics? And it turns out there's the core statistic, but also for something to be a statistic, what does that mean? And we'll talk about that also. Then we'll get into charts, and this is visualization of statistics, or the data. And you've all seen it, at least in some of the charts. You've all kind of looked at a histogram or some other chart, a pie chart, things like that. But you haven't necessarily kind of looked at the details of them and look at some of the more difficult ones to understand, that you have to truly understand the statistics to be able to understand the charts. Then after that, I'm going to get into the Z-score. I'll explain what that means later, but right now, just trust me that that's an important statistic that you really don't learn until you take statistics. Because whereas things like the average, hopefully you learn that in elementary school, and there's some others that you learn the maximum and the minimum. But Z-score is one that's a new one. And then we'll also talk about variables and the different types of variables you can have. And I'm not sure if it'll be the last thing we do, but it'll be throughout. So that is the plan for today. And I want to remind you a couple things. What I do is I make sure that the webinar covers whatever it is that we're doing that week. And due this week will be chapters 1 and 2. So you'll have to do the assignments for chapter 1 and assignment for chapter 2. You'll also have to do a discussion post. Besides the really easy one, there's one really easy, it's just the 2 truths, 1 untruth. That's like, shouldn't take more than a minute to do. But then the other one is really learning about statistics, and this will help you understand that a little bit better. So that is the plan. Next week, we'll have just one chapter, chapter 3, but we'll also talk about the project and go into more of the details, because the project, the project is mostly on chapter 1 and 2. That's kind of what it's about. And chapter 1 and 2 are really important chapters. They're not necessarily that hard, but they're really important. So are there any questions that you have? I'm always happy to answer questions if you have any questions. So this is a great time, and one of the big points of the webinar is so that I can immediately answer your question, give you help, explain things that maybe you didn't follow while I was talking or whatever, showing you something. So, make me happy and ask questions. Look at it that way. Any questions?
Hi, Larry. Sorry, I stepped away for a second. To clarify, chapters 1 and 2 is due by Sunday?
Yeah, I would like to say it's due Friday, but you get an automatic extension till Sunday.
Okay.
That way, because the idea is don't wait until the very last minute.
Yes, no, I get that. Just with my work schedule, I can just
Mhm.
see in the future it be in Sundays for me.
Yeah, yeah.
Okay.
But yeah. It's a Sunday pretty much for almost everything we do will be your last chance of doing something. The only thing that you have to do every Thursday, and
Okay.
that is the initial discussion post.
Got it.
Because the problem is that if I say, oh, you have your last chance will be Sunday, and then at 11:59 p.m. on Sunday night, you post your discussion post, that doesn't give anyone time to answer.
You want a chance. Gotcha.
So that's why I have that one by Thursday. And so hopefully that'll be fine. And again, if you ever have questions on the thing, post on the Q&A forum. If there's something you're doing and you can't figure out how to do it, then I'll be happy to help you out with it. And the tutors also can help too. Okay, great question. Great question. Other questions? Okay, if there's no questions, one of the things, and we all have our style, something that to me makes a lot of sense is to actually kind of use what's current in explaining. The great thing about statistics is it's not like algebra where you like, where am I ever going to use this? For me, when I teach this stuff, it's like, all right, which of the 10 things should I go over that's in the real world right now? And so I decided today, I got an email actually that said there was a flu and COVID vaccination clinic. Okay. If you're in Tahoe, by the way, you can come too. And it's multiple different days throughout, but maybe hopefully in your town they have it too. And then very soon after, I read an article. And it was an article on CBS News. And it said about half of Americans plan to skip COVID and flu shots. Okay. And by the way, do you think that's a good thing? What do y'all think?
Since I'm currently sick, I'm going to say they should get their vaccination.
Yeah, well, I'm sorry you're sick. That's never a good being sick is not a good thing. But yeah, and I will tell you, and you can trust me on this because I am a statistician. I have fully researched the statistics they did on both the COVID and the flu shot. I do that beforehand just to make sure they do things right, and they did it right. And I'm going to be getting my COVID and flu shot for sure, because statistically, you're better off getting the shot than not getting the shot. And again, I'll go over a little bit how I know that, and how the country knows that. It's not like me personally. I just understand it a little more thorough statistics wise. But they did the right thing in terms of the Center for Disease Control. So then what I did is at the bottom, it's like they always put at the bottom. And the reason why they are usually put at the bottom is they usually put the discussion of how they did the data collection at the bottom because most people don't want to read it. But in my opinion, I think it's important to see after reading an article, is it something that you rely on or trust, or are they just making stuff up? So let me read, and again, this is just a copy and paste from the article that I read, and that was the CBS News. So I've given the source, and this says a survey was conducted on behalf of the Ohio State University Wexner Medical Center by SSRS. Don't ask me what it is. I have no idea what SSRS is, on its opinion panel omnibus platform. SSRS, I guess it is opinion panel omnibus. I guess that's what omnibus, I wonder what the S is a national twice per month probability-based survey. Data was conducted from August 16th to August 18th. Okay, so not that long ago, not yesterday, but 2024, pretty recent, among a sample of 1,006 respondents. The survey was conducted via web, N equals 975. and telephone, n equals 31, and administered in English. The margin of error, let me do this so we can see the whole thing at once. Okay, the margin of error for total responses is plus or minus 3.8 percentage points at the 95% confidence level. All SSRS opinion panel omnibus data are weighted to represent the target population of the United States adults ages 18 and older. All right, so I want to kind of look at this and really try to understand if they did what they're supposed to do, what we can get out of it. Are there issues in what they did? What does it mean what they said? Because there's a lot of detail there. I'm not sure how many of you read the bottom of an article and read this part of articles, but many, many articles have this like as a last paragraph, or at least some paragraph, but usually last paragraph. Sometimes it's a link to this that you can read. And I want you to all understand that because I think it is very important to be able to read an article and look at it and critique it. Did they do their job? Is it trustworthy? And some of this stuff we're not going to get to for another few weeks, like 3 or 4 weeks. And that'll be this part right here. And that is the margin of error for the total responses was plus or minus 3.8 percentage points at the 95% confidence level. We actually are going to spend an entire full week just on basically that sentence right there. You know, how to understand that sentence, because it's really, really important to understand what it means to have a confidence interval and a margin of error. And that again, that's not today. So I'd like to let you know that we're going to be learning a lot more in this class. So we can't fully understand any article in the first week of class, but we can understand pieces of it. All right, so what I want to look at is a few things. One is the survey question, probably 2 questions and maybe 1 question. And hopefully it's somewhat obvious. The wording you can't tell just from this, but it's probably, do you plan to skip COVID and flu shots this year? Okay, and what's important about this is a yes/no question. Okay, hopefully you can all see just from reading this headline right here about half Americans plan to skip COVID and flu shots, that this is a yes or no question. Okay, the people are not going to answer with a number, the individual person. Any questions on that? Okay, so we're going to spend a lot of our class talking about how to analyze yes/no questions. And we're also going to spend a lot of our class talking about how to analyze questions that are quantitative, which means there's a number answer. Okay, and that would be something like, instead of do you plan to skip COVID and flu shots, it would mean more like, on a scale of 1 to 10, how important do you think it is to get your COVID and flu shot? And that would turn it into a quantitative survey question. Any questions on that idea? Yes, no questions are an example of a qualitative. Qualitative means you don't get a number as an answer. And yes, no is a special example of the qualitative. There are other qualitative survey questions that could happen in, other ideas, things like, what is your favorite color, right? Unless you're a physicist, to you, that's a word. It might, for me, you might be able to guess my favorite color because of my name, and that's green. But I don't know if any of you have a last name that's a color, but mine happens to be. But the point is that you don't say yes, no, you don't say 73. It's a word. Another would be what state or country were you born in? If you were born outside of the country, and that's another word. It's not a number. It's not yes, no. Any questions on the idea of that? Okay, then what you want to do is you want to say, well, what did they do to try to make the sample representative of the population? So one thing, and this is something that you might be a little concerned about, the article, the headline is about half of Americans plan to skip COVID and flu shots. They asked 1,006 respondents. Do they know about every American? What do you think? So say about half of Americans. What do you think? Yeah, they asked 1,006. I don't know if you know, but there's something like, I don't know, 250, 240 or 250 million Americans. And if you only look at those at age 18 or older, it's still, over 100 million adult Americans. And they asked 1,000. That's nowhere close to the number of Americans. I know they didn't ask everyone because they didn't ask me. By the way, did they ask you? I have never had anyone say yes in a national survey where I show something like this. It never happened because the probability is so low, and we'll talk about probability next week. So not very unlikely to be asked. So why can they talk about all Americans when they only asked 1,006 respondents? And the key here is, did they have an unbiased study? Okay. And I don't know, do you know what the word bias means? Have you heard that word before? Any ideas on what bias, when I say unbiased? So what it means to be biased or unbiased? That's not like a fancy stats word. It's a word that's used a lot. So my guess is you've heard it. Let's see, you're all jumping in on the chat box. Hey, maybe you've heard it and you don't want to tell me, or vice versa. I don't know. So the idea here is that a bias study means that the people that you ask are likely to be different from the general population of America. In particular, for this study, that would mean the people that you asked are likely to be either have a higher percent or a lower percent planning on skipping the COVID and flu shots. Does that make sense? Then all of America. And if it's likely to have higher, then you say it's biased. If it's likely to be lower, you say it's biased. If it could be a lot higher or lower, but kind of if you did this a lot of times and the average would be about what it is in America, then it's unbiased. Does that make sense? So one of the hardest thing about a study like this is to get an unbiased study. So what they did to help reduce the bias, okay, to get no bias is pretty much impossible, but to reduce the bias, there's some things they did. And what they did, and it says here, is right here, the data are weighted to represent the target population of US adults ages 18 and older. Okay, I'm not going to get into the idea of weighting. I'm going to give you the idea of stratified sampling, which is kind of a simpler form of what they did. So what the idea is, you want to say, well, we want to make sure we represent the target population. So to represent the target population, what do you think you have to make sure of? Any thoughts? What kind of people do you need to ask? What do you have to make sure of with the people you're asking to make sure that you have this representation, which is another way of saying unbiased? Any ideas on what you want to make sure of? Okay, US citizens, I think they didn't, let's see, they don't have to be citizens. And by the way, I'm not going to get political because I can get in trouble for that. But they just said half of Americans. So does that mean you have to be a citizen or just a resident? I'm not even going to go there. Okay, so ages is important, and not necessarily just all ages. Because you don't want to have the same proportion of people who are, say, 100 years old as people who are 30 years old. Because that would be biased because there are a lot more 30-year-olds in America than 100-year-olds in America. I'm hoping you know that because most people don't live that long, right? So what you want to do is not just have an equal amount percent for each age, but you want to make sure that the percent of each age that you survey is the same percent of each age of Americans. Does that make sense? So you got the idea of ages as being important, but it's a lot more detailed than that. It's the percentage that you survey should be the same as the percent in the population. Okay, besides ages, what else might you want to make sure of to make it unbiased? Besides not to have an age bias, what else could you have? Okay, good. So that might be where they're living. Okay, so where in the United States they happen to be living. Okay, now that does not mean they should look at the 50 states and survey the same number of people in each state, because, for example, California has a whole lot more people than Nevada. So you're going to be surveying more Californians than Nevadans, so that the percentage of Californians that you survey is the same as the percentage of Californians in America. You see how that works? Other typical things that you would make sure that you keep from being biased, and that would be gender, because you don't want to ask only men. You might want to also survey based on maybe political. So maybe your political party. So whether you're a Democrat or Republican or Green Party or whatever party you might be. So, and again, you want to make sure that that percent is the same. And that's what they basically did. I'm not going to get into the weighting part because that's past what we do in our class. That would be the next course in statistics, but you get the idea. So let me tell you what it's called. It's called stratified sampling. Very important. It is the most common form of sampling method of doing a survey of large populations of people, like Americans or Californians or people on Earth. And that's stratified sampling. So it has a step-by-step process. So what it means is you determine the strata, such as age, gender, income is another strata you would do. And there's lots of others that you can do. In our class, when you're going to have to do something, we'll just stick to one of them. But in the real world, you do a bunch. It's just too much work to do a whole bunch. And I'm not going to make you spend 30 hours on, figuring out a good system. I just want you to understand the system, if that makes sense. But in the real world, you have to do a bunch of different strata types. Okay. And then research the percentage of each group from the population. That's often pretty easy. So for example, if I were to do it and we were looking at the United States population and we wanted to look at gender, I would just ask Google, okay, or whatever AI system, and I'd say, what percentage of adult Americans are male? What percent are female? What percent are other? And then in 5 seconds, it'll tell me. That's the good news. In the old days, it wasn't like that, but now it's so easy to get kind of these main strata percents of, say, all United States residents. Any questions on that? Okay. Then what we do is we decide what our survey size is. What their survey size was 1,006. Okay, so let's suppose we did, I don't know, stratification by gender, and let's suppose that we found that 49%, I'm making this up because I didn't ask Google. Let's suppose we found out that 49% of all American adults were men. Then I would take 0.49 times 1,006. And that would give me, I don't know, 528 or something like that. I'd use a calculator. And then that would be my established quotas of the men. I do the same for the women to get their quota and the same for the others. Then you conduct the survey, making sure that each quota is exactly established. So once you have established your quota, so if you have to do 528 men, then you have to ask exactly 528 men As soon as you've asked the 528th male, you don't even ask any more men. Any questions on that idea? And the same idea for women and others. Any questions on kind of how stratified sampling works? Okay. It's not that hard to do. Nowadays, it's usually not that hard to find the population percents. Multiplying the percent times your sample size is really easy. That's a 2-second thing. And you're just surveying people. It just means you have to ask one more question or a few more questions if you're going to do multiple different types of strata. And that's stratified sampling. It's the most common sampling technique that you'll see in surveys by far. Doesn't mean there aren't others, but that's the most common. We'll talk about others in a little bit. Okay, so I just want to remind you, so it's in writing since I mentioned it. Qualitative means that the answer to the survey question is a word. Quantitative means the answer to the survey question is a number. So whenever you have to decide, is it qualitative or quantitative, what you should do is say, what would the survey question be that I would ask that individual person? And what answer might that one person tell me? If that answer would be a number, then it's quantitative. If the answer would be a word, it's qualitative. Any questions on these two main words? Okay, I do want to mention something that's very important, and that is chapter 1, especially, has a lot of vocabulary. So be ready for a lot of vocabulary. Notice we haven't even talked about any math yet. I guess we wrote the number 1006, but right now it's just a lot of vocabulary. Later, as soon as we get to chapter 2 and beyond, then there's a lot of number stuff involved, a whole lot of number stuff. Chapter 1 is just all vocabulary, pretty much. So make sure that you keep up with that, or you're going to be lost in all the questions and sentences because they're going to use these vocabulary words a lot. Okay, so the sample size. So the first thing is it is standard, not just our class, but pretty much all of statistics. You always use the letter lowercase n, and that's the sample size. So anytime you see lowercase n as a variable, that's the sample size. I don't think I've ever seen it used for anything else in statistics. So the sample size is n, and in this case, n equals 1006, and that is the sample size. Just a guess, do you think that's a big enough sample size to have pretty good data for news articles? When you have, hundreds of millions of people in America, do you think that's a big enough sample size? What do y'all think? Okay. So this is kind of a trick question because you haven't learned statistics yet. The answer is yes, it's a big enough sample size. Okay, I know you probably think, well, that's a tiny size, but we're going to get into the math and we're going to realize that if you have an unbiased study and you have a sample size over 1,000, actually, you have very, very good data and you can really get a lot of good results. It feels wrong though, doesn't it? Okay, so it's not how big the sample size is compared to the population size. It's just how big is the sample size. And 1006 is actually big enough for the qualitative. For quantitative, you don't even need anywhere near 1006. Okay, smaller is fine. Okay, a sample size of 3 is bad, by the way, but 1006 is fine. So trust me on that, and we'll see that. We'll do some calculations in another 4 or 5 weeks and show why that's good enough for most things. Okay, so now I want to talk about what is a statistic and what is a parameter. So a statistic is a number that comes from the sample. So that would be the percentage of the 1,006 people who were surveyed that are not planning on getting vaccinated. that's a statistic because that would be the 1,006 people, and those 1,006 people are the sample and not the population. The parameter is a number that comes from the population. And that would be the percent of all Americans who do not plan on getting vaccinated. Okay. Typically, you can't even get the parameter because good luck asking every single American that survey question. You know how long that would take you? By the time you're done, it'd be many, many, many years ahead from now because good luck. And then you'll have new Americans. It's just not going to happen. So parameters are usually in theory. Okay, they're there, but we'll never know them. Statistics we can actually get. And the class or the course statistics means that you're going to use statistics to make a really good guess, hopefully a good guess, or a good estimate for the parameter. Any questions on that idea? Okay, so a big part of what we're going to be doing in this class is one, deciding what statistics to use, and another is deciding how good an estimate the statistic is to make that estimate for the population parameter. Any questions on that idea? So it's really, really important. A lot of language today. Okay. So let me go over most of the sampling techniques that are done. We already went over stratified sampling, which I think is really the most important for good research. Then there is random sampling. Okay. So let me ask you something. Can you pick a random number between 1 and 10? Put it in the chat box. Pick a random number between 1 and 10 and put it in the chat box. Give me a random number between 1 and 10. Wait until you all have it. Okay, so here is my guess. I might be wrong. My guess is you didn't do what I asked. Because if you just came up in your brain with a number between 1 and 10, thinking that you're doing it randomly and gave me that number, it's actually not, we can't do that. Humans don't have the ability to do that from our brains. And there actually has been studies in psychology, by the way, in showing that we do not have the ability to pick random numbers in our brain. There is a way to pick a random number. My guess is you didn't do it this way, but maybe I'm wrong. And that is ask the computer to pick a random number between 1 and 10. I showed you, I think I showed you yesterday how to do that, actually, when I showed you the calculator. Okay, computers actually can pick random numbers. Okay, they do a good job. I will not get into the details of how it's done with how the computer does it and the processing system and the programming and all that. That's my coding stuff, and this is not a class on coding. But you can trust a computer to pick a random number, but you cannot trust a person to pick a random number. That's just a note. And that's true of just about everything with people, is we can't pick random people thinking that we can just walk around and grab a random person who's walking by. It turns out we don't have that ability psychologically to do that. They've done studies, statistical studies on this, and they found that people are actually more likely to pick someone like themselves than someone who is less like themselves. If you ask them to pick someone random, they don't. They pick someone closer to themselves most of the time. Kind of cool stuff, isn't it? So random sampling means that every one has exactly the same probability of being chosen as every other one. Okay, and that could be people in America, if that's your population. If you want to, pick a random pine tree in the Sierra Nevada forest, then every tree would have the same probability of getting picked as any other tree, which is not easy to do. Does that make sense to everyone? So just to note, random is hard. Okay. The only way to really do it is to use a computer and make sure that every item in the population is in the computer's database with a number, 1 through n, capital N, where capital N is the number of population size. And then you ask the computer to pick a random number, and it can do that. Then there is a special kind of random sampling, which is simple random sampling. And that means you're going to pick a random number from 1 to n and then survey. And it's really hard to do that. So you're not going to be able to do that for people in America because a lot of people are hard to find. It's just not going to be able to find a lot of people that are hiding away. Okay. Or if you call everyone and email, what about the people that don't have a phone or email access? They'll never get picked. Okay. Or let me ask you this. Put in the chat box, yes, if you've ever been called, maybe on your phone, on your smartphone, by some surveyor and did not answer their question or didn't even answer the phone when they asked. So click yes if that's happened to you when you didn't answer. I'm a yes, by the way. Okay. All right, I'm seeing you saying yes. And that's pretty much everyone's done that before. And then some people are much more likely to do it all the time than other people, which means you have a big problem right there. And if those kind of people are also more likely to say yes than no on the survey question about vaccination, then all of a sudden you have bias. That makes sense? So it's really hard to avoid that kind of bias. And that kind of bias is called voluntary response bias. Because when you do a survey, which is most surveys are done that way, where you call someone on the phone or you ask, send them an email, or maybe even ask them outside the grocery store or whatever it might be. If people don't want to answer your survey question, you can't make them answer your survey question. Any questions on that? Okay, so that's why simple random sampling and random sampling are almost always impossible for people. That makes sense? Okay. Stratified sampling, as I mentioned, there's 4 steps, and I want to make sure you understand each of the steps. Decide the strata. That might be what state you live in, or gender, or whatever it might be. Research the percentage of each type from the population. Multiply the percents by the sample size to establish quotas, and then conduct the survey, ensuring that the given quotas are met. Okay, then there's a next one that is also really helpful, and that's called cluster sampling. Let me explain how this is done. It's done in a few places very commonly. One is at colleges and universities. So the idea here is you can pick what's called representative clusters. Okay, and those clusters are going to be groups. If you're surveying people, be groups of people. Okay, what do you think the easiest groups of people, if we're talking about college students, are to ask? What groups? How are you going to group up people? Any thoughts? The problem with by grade is that, especially at a community college, we don't have grades. We have first year, second year, basically, maybe third year. But the problem is you're going to have to ask everybody in the chosen groups, and that would be everyone in the whole college, which you can't do. So the groups are too big if you do by grades. Okay, the problem with athletes is that athletes are different kinds of people sometimes. What about the non-athletes? For example, I wasn't, I was an athlete, but I wasn't a weird kind of athlete. I was an ultimate frisbee player when I was in college. But there's a lot of people that are just not athletes. As soon as I tell you, it's going to be so obvious. Should I tell you? Gender's a problem because, again, you have to ask everyone in a certain group. Do you see? So if you ask every male, that's too hard. Okay, let me tell you the clusters that are used just pretty much, I wouldn't say every time, but most of the time. Classes. You walk into the classroom and you ask the students in that class. And then you make sure that you have representative classes that you ask. So you're going to ask some online classes. You're going to ask some face-to-face classes. You're going to make sure that you ask some transfer classes, if it's community college, and some non-transfer classes that are representative of the college. Does that make sense? Not every class in the whole college, but you're going to just ask some representative classes. And then you're going to make sure that everyone in the class answers a question. And often if the professor asks you to do it, then they're going to answer. Just to let you know that. So it's a nice way of doing things. And that is an example of cluster sampling. Okay, let me give you another example of cluster sampling where the population is not people. Let's suppose the population were the one I just gave, pine trees in the Sierra Nevada forests. Okay, and by the way, if you don't know the Sierra Nevada forest very well, let me just tell you, it's huge, hundreds and hundreds of miles long. Okay, there are millions, maybe billions of trees, of pine trees in the Sierra Nevada forest. And let's say you wanted to find, say, the average height of the pine tree in the Sierra Nevada forest. Then you can't measure the height of every pine tree. Nobody's got that kind of time. But here's what you can do. You can do cluster sampling. What you can do is you can take a map and you can cut it up by acreage. So you make a grid of the Sierra Nevada forest on a map by acreage. You pick some representative clusters, and that might be some at the higher elevations, some acres at the higher elevations, some that aren't so high, some that might be near water, some that might be not near water on kind of the east side that may not be near a stream. So you would make sure that you have representative acres, which are the clusters, and then you would go to maybe, 10 or 15 acres of that are selected that are representative of the forest. And then you would measure every tree in each of those acres. Okay, it would take some time, but that's something you could do, and it wouldn't take years to do. Any questions on that idea? On how cluster sampling works? Okay, so the next is systematic sampling. And that is you survey every nth item in the population, where n is a number. So that might be every 100th person that walks by. Okay. Another way this happens in manufacturing, and actually I did a consulting a little bit, and I consulted for a company that they were making towels for hotels. That was what they made. And they wanted to show that they were better than China, the ones made in China. This was a former student of mine that had this company, and he asked if I could help him. And let me tell you what I told him, and I'm going to tell you the same thing, is that if you graduate from your college, get your degree, and have have your company, and then need some statistical consulting, and you want to ask me, I will do it, but at a cost. And here's the cost that I do. I don't want you to give me money, but I do want you that if you have your own company and you would have paid someone to do it, but you're going to ask me instead, I want you to donate money to a scholarship. Sound good? So that's the one thing I ask. So that could be 10, 20 years from now. I don't know if I'll be alive in 20 years, but the point is it'll be, after you have your own company. If you're a student and you need some help, I won't charge you. I won't ask you for money, and I'll help you out. Okay. And that could be after you're, done being my student, and I'll be around as long as I'm around. Sound good? So that's my rule. I'll remind you that later on in the course too. Okay. So, and actually, there is a pretty good scholarship at the end of the year for at our college that has been funded by this, which is kind of cool. So I had this company, they were making towels, and what I had them do is I had them, what they wanted to do is show that their towels lasted longer than the ones made in China. So I had them grab, I think it was like every 500th towel that came down their assembly line of towel manufacturing. And then I had them take those towels and then do the heavy washing and dirtying of the towels, however many times they said that they needed to like show how long they lasted. Look how long each of the towels lasted on average, and then compare that with something similar made in China. And actually their towels did better. Isn't that cool? And that was systematic sampling. And there's really no bias in doing that. The problem is this every nth item. So if we're talking about Americans, two big issues. One is you're never going to be able to list every American and understand you are the 300 millionth, 300 millionth American. Good luck. It's not going to happen. So there are a lot of situations you can't do this because you can't order them and give them all an ordered number. And the other is you have to make sure that you can get a hold of every item. And if it's Americans, you can't get a hold of every person. Okay. And sometimes it just takes too long to find them, whether it's Americans or whatever you're looking for. So it works really great in manufacturing. There's some other things it can work in. It can also work in, let's suppose you're the manager for Safeway supermarket. Then what you can do is if you want to see, how are people reacting to something you might say, then you say it, see how they react, then wait for another, 50 customers that come through, and then say it again and see how that person reacts. And then you don't have bias. Any questions on that? Okay, then there is convenience sampling. Okay, and convenience sampling means you just collect data on whatever's easy. Okay, so if you want to survey Americans, just go ask your friends. And whoever answers, use them, that's your data. What's the problem with convenience sampling? Any thoughts? A lot of problems. Yeah, so let me use the word we've been using. It has a huge amount of bias. Yeah, it's biased. So let me give you an example of where convenience sampling can go really wrong. Let's suppose that in my lifetime I wanted to find out the average age of math and statistics students. No, sorry, the average height of math and statistics students. Sounds like a nice thing to do. And so what I decided to do is I'll just go to the first class that I ever taught, measure their height. Any guess on what you think the average height of my first class was? Any thought? Okay, I'm going to tell you and you're going to go, oh my God. 6'11". Yeah. Any guess who I taught? Yeah, the UCLA basketball team. The first class I ever taught was the UCLA basketball team, and they were so tall. Okay, it was pre-calculus. So be careful about, doing something like that because you'll end up with a really biased sample. Don't go to a basketball team to get an average height of Americans because they're your friends because you play basketball or something. That'd be a very bad idea. So convenience sampling should never be used when you want reliable data. Got it? Okay, you just don't do that. Okay, let me give you one more kind of sample that's really important in medicine. Any of you plan or want to go into some kind of medical field? So I often get those as students. Yes or no? Okay. All right, we got a yes. Okay. I almost always get some yeses. It's a common thing to go into for taking statistics. So let me give you the example, kind of, I think was the most important study that was done in the last 5 years. Any guess on what that was? Most important statistical study in the last 5 years. Any thoughts? Yeah, the COVID vaccine, in terms of COVID, the COVID vaccine. Okay, so that was, it was like 4 years ago. Okay, where they had this vaccine idea. They wanted to find out if it worked. And what they wanted to make sure is they have an unbiased study. So here's what they did. Okay, this was Pfizer, by the way. So by the way, before getting my vaccination shot, like I said, I make sure they do things right. They were able to get a group of volunteers. By the way, you can't do a human study on a vaccination that's not volunteers. Okay, you can't force people to get vaccinated on a new medication that's never been tried on people before. You can only get volunteers. And what they did is they actually had a sample size of 40,000, which is a lot. Okay, again, I looked at this stuff because I cared, not just for teaching, but I wanted to make sure that they did it right before I got vaccinated. They had a sample size of 40,000, which is pretty good, really good, by the way. Then what they did is they put their names into a computer, and along with a number for each of them, first person, second person, all the way up to 40,000th person. And then they had the computer split the people randomly, purely randomly. Computers are really good about random, into 2 groups. And the 2 groups were the control group and the treatment group. The control group, what they did is they got a shot of basically nothing in it, no medication at all. The treatment group got the shot of the vaccination that may or may not work. Okay, and this is real, by the way. And the people who got the shot did not know whether they were control or treatment when they got the shot. And in fact, the people giving the shot didn't either, and you call that a double-blind control study. If the people giving the shot know, then it's called a single-blind control study. If neither know, it's a double-blind control study. Okay? And then what they did is they waited some months. I don't remember how many months. When it happened 4 years ago, I looked at it, and they waited a good number of months to see what percentage of those who got the shot that were the treatment group got COVID in those months, and what percent of those who got the shot that were the control group that had no vaccination in it got COVID. And they compared those 2 groups. Okay. That is a very well done study because it's randomized and it's double blind. Any questions on that idea? Any questions? So that's a study that you can trust because there's no bias at all. Isn't that nice? Okay, there was no bias. It was a pure double-blind study, and they found out who got the shot that was the treatment and who got the shot that was the control. Okay, and I'll let you know, and this is kind of a personal thing. When I was in college, I was a volunteer, not for COVID, by the way. It was way before COVID, but it was a volunteer. I had diarrhea at the time. It sucked, and they needed volunteers to get a shot. And actually, I think it was a oral medication, and then a week later, they found out, how long it took to get rid of end of diarrhea. And the bummer for me is I was in the control group and I didn't get better. It sucked. But they paid me. They paid everybody, by the way. So I know it personally from the other side too. I don't know if any of you have been in control or treatment group, but it's common. Any questions on all these different kinds of samplings? Very important sampling techniques, and they're complicated. Any questions on these types? These are the main ones that are used. There are some others, but these are the main ones. These are the ones we do in our class. Okay, it's a big deal. Okay, so here comes the next definition, and it's the definition of statistics. What is a statistic? Very easy. A statistic is a number that is calculated from the data. Okay, and you know some of these statistics. Okay, and it's from the sample data, not from the population. Okay, I mentioned that already, but now I want to give you a bunch of statistics. The first one is the mean. By the way, mean doesn't mean you're evil. It's one of these weird synonyms. What's another word for the word mean that you got in elementary school? My guess is you probably know. What's the word? What's the simpler word for mean? Do you know? Let's see, jumping in. Okay, the simpler word for mean is average. Okay, so it just means you add them up and divide by the total. That's the mean. Okay, we're not going to do any of the arithmetic in this class, or not in major arithmetic, but average is something that you learned at one point. Another is a median. Do you know what the median is? It's another one that you probably learned in your K-12. Because, and especially if you're younger, because and not just median, but all of these actually, they do a lot more stats nowadays, now than they did, say, 15 years ago. Yeah, so the median is the middle point. So what you do is you take all the data values, you order them from lowest to highest. And if it's an odd number of values, you pick the one in the middle. If it's an even number of values, then there's actually two middles. So if there's 8, for example, then these two in the middle, right? There's no single middle. So you take the two middles and you average the two. And that is the median. Okay. Any questions on that idea? Okay, the mean and the median are important, and they're important for different reasons. I'd like to give an example on house prices. Who would care more about the mean than the median, and who would care more about the median than the mean? Any thoughts? Who would care more about the, say, median than the mean? And I know not everyone's from Tahoe, but especially in Tahoe. But it might be in your town too if you're not in Tahoe. I don't hear. Okay, let me give you an example of who would care about the median. Let's suppose that you wanted to find out kind of what normal people in town are like. Okay, what a normal house is like in terms of you want to live in Tahoe, and you're not one of the weird extreme people, like one of these billionaires, then you just want the median house, and that's like your typical house. Does that make sense? Okay, and they would definitely care. On the other hand, the mean, there's very few houses in the mean because Tahoe, we have like $40 million houses. We have like these super houses. By the way, my house is really close to the median because I'm a teacher. So the mean would be much higher than the median because that $40 million house would bring up the mean really high, but it wouldn't affect the median pretty much at all. So the mean gets affected a lot by outliers. Outliers are really high points or really low points. The median doesn't when you have a large sample size. Got it? Okay, in terms of who would care about the mean, that might be our city council because their funding comes from taxes. And that $40 million homeowner is paying a huge amount of taxes for that house. And it's important because they're bringing in a lot of money into the city in their taxes. Do you see that? So if you're thinking about the tax revenue, the median is a lot more important than, the mean is a lot more important than the median. Any questions on that idea? Okay, then there's the standard deviation. Okay, I'm not going to get into the mathematics of the standard deviation, which is going to be true of just about everything we do in this class, because it's too messy, but I want to get into the idea of it. So the standard deviation is a measure of how spread out the values are. Okay, so it's kind of an average from the average. It's an average distance from the average. Okay, so if all of the data values are kind of really close to each other, you can have a very small standard deviation. If the data values are really far apart from each other, you can have a large standard deviation. Or if you have not that many data values, but you got one that's really, really far, that's going to move the standard deviation up high, make the standard deviation far. Whether that outlier is way over low or way over high, the standard deviation will increase because the measure of what the distance is, kind of an average distance-ish. Okay, it's not exactly average distance, but kind of the idea of that. Any questions on that idea? Okay, the first quartile, we'll use Q1, is what most people write. And by the way, let me just do first quartile. The median is that middle value. If you order everyone, it's the one that 50% on the left and 50% on the right. The first quartile, it's kind of the idea, instead of 50% that are below you, 25% are below you. Okay, or at or below you. And the third quartile, same idea, but 75% are kind of below you. Any questions so far? The IQR, which is the interquartile range, is the distance between the first quartile and the third quartile. And what that gives you, the IQR, and sometimes you say from first quartile to third quartile, and that'll give you your middle 50%. So the middle 50% of the data will be in that interquartile range. That's very important for advertising, for example, because a lot of times you want to advertise to the middle, that middle group. Any questions on that idea? Okay. I want to note something. This is not an accident. Notice standard deviation is much higher font. I put it in bold. Any guess on why? Any guess on why I did that? No, it's not the secret word. That was a good try though. Okay. It's one of the super important. It's one of the most important. It's one of the most important statistics in all of this course. The mean is really important also, but that's the average, and I think everyone knows the average, and you get a good feel for it. The standard deviation, not everyone really has a good feel for it, and you need to have a really good feel for it in this class. Got it? So that's really important. There's a measure that looks at the mean and the standard deviation and compares them, and that's called a z-score. So z-score has a formula, and that is, I want to show you the letters here. It's x. X is a given value minus mu. Mu is the population mean of the entire population divided by sigma. And sigma is the population standard deviation. Don't get mad at me for using Greek, because that's what everyone uses in statistics. Everywhere in the world, actually, because everyone uses the Greek letters, I guess. Okay, actually, I haven't been in China, but I know in Japan they use sigma and mu. And I know in Europe they do also. And a lot of other countries I've heard too. So everyone uses mu. And the way I like to remember it, do you know what I hear when I come home? Meow, meow. You know what that is? You might hear it at your house too. I don't know. You might not. Yeah, it's my cat. It's not Kitty because she's 19 years old, but she's my cat. And so just remember this is meow. You remember that? Because we're going to be using it in the entire course. Okay, it is like these are the most important symbols in the entire course. And sigma, that one doesn't have a nice animal sound. Sorry about that. But that's how you say this letter here. And learn how to write it, learn how to draw it. In a computer, you go to Greek and you can type in, you can find mu and you can find sigma. It's all there. And they're very important. Okay. All right. There aren't really enough of you here to do a really good statistical data because you need a sample size more than a few. So maybe I'll make something up, but I want to show you with the calculator how to do that. Okay. Let's actually I got an idea. I'm gonna have you put in some numbers in, and this will be a total convenience sample. All right, let me pop in, and I want to go to one variable statistics calculator. It's going to be an important one. And I did show you before, but we want to use it and look at everything. Okay, so let's do a survey where I'm going to ask you a survey question. It's going to be kind of multiple somewhat questions. And let me ask you, among your top 5 best friends, how many miles are they from where you live right now? So type in 5 numbers. Think of your top 5 best friends. How many miles do they live from where you are? And by the way, you're just guessing is fine. If you don't know exactly how many miles your friend is, just give it a good guess. I just want some numbers to put in and put that in the chat box. Nice little study that you can do. This is convenience sampling, so you would never use this method for any kind of scientific research. So let's see if you can put in just your best guess of your 5 best friends miles from where you are right now. There'll probably be possibly 5 very different numbers. And again, just guess. I don't care if you have like very accurate data. Okay, here we go. So let's type them in. So we have 40, 46, 43, 59, 106, 25, 22, 18, 20, 23. Okay, so none of you have any friends that are like on a different continent right now. It's kind of clear, which is fine. All right, I'm going to consider this being a sample. We'll call this a sample because again, I just asked you for 5 friends. I just asked a few of you. And so I'm going to click on sample standard deviation. And it turns out the formula for population standard deviation and sample standard deviation, those are different, slightly different formulas. So you'll get different numbers. All the rest are the same numbers. And they calculate. That's 40, 46. I wonder if I have a period instead of comma. Let's try. If it says NaN, yeah, I think I did period instead of comma. Sorry about that. My guess is you might make similar mistakes someday. Not exactly this one, but if you ever get something like NaN, then look to see what you might have typed wrong. Let's try again. I think it'll give me that. There, much better. All right, now we can look at what we have, our statistics. So the mean, which is like the average, but when you're doing it in our class, I want you to use the word mean and not average, okay? Promise me you're going to use the word mean and not the word average when you have to type in something, okay? And that is 40.2 is going to be the mean distance of friends. The minimum was 18 miles. Wow. So none of you have like a friend that lives like in your little neighborhood. It's interesting because that's a really low minimum. Okay. Q1 is 22. So that's like about 25% of all friends live within 22 miles of you. Okay, of people. Okay, you see how you can get information from this stuff. The median is 32.5. So that would mean that if you drew a circle 32.5 miles from you, then half your friends will be in the circle and half friends will be outside the circle. See how that works? Q3 is 46. So that means that 75% of all friends are within 46 miles. Any questions on any of these? Please stop me if there's anything you're not understanding. The maximum is 106. So the farthest away friend for this data is 106 miles. Okay. By the way, if I put my data in, it'd be much higher. I have friends that are like thousands of miles away. Right now, at least. Okay, standard deviation. About 20, I'll call that 27. I'm just going to round to the nearest whole number. About 27. So that means that there's a pretty big variation from friend to friend and how far they are from you. Because 27 miles or so that's pretty many miles, right? It takes a while to drive there. It takes a long time to walk. Okay, so do you see how what the standard deviation tells you? Kind of gives you kind of an average amount of variation there is from distance from friend to you to other friend to you. Any questions on that idea? Just to note, variance, we're not going to do much in this class. There's a lot of math that's important, but that's basically the standard deviation squared. Here's a suggestion for the project. Don't even mention the variance and you'll be better off. IQR is 24. Okay. Notice if you take 32 minus, if you take 46 minus 22, you get 24. So that means the spread of the middle 50% of distances for friends is 24 miles. And the sample size, N, is 10. So that means that we looked at 10 friends. Any questions at all on looking at the statistics? Notice these are statistics and not parameters because I'm considering this as a sample of all students and students' friends, I guess I should say. Any questions on the statistics, any of these statistics that are really important? Okay. Do you agree that it's not that hard to use this calculator? You have to remember to use a comma, not a period. That was my mistake. Sorry about that. But I tried to make it easy. And if any of you have a suggestion on how to make it easier, let me know and I'll do my best to make it easier. When I first made this calculator, it was a lot harder. And then all the suggestions helped you guys out because now it's easier. Any questions? Okay, so let's go back. And now let's talk about standard deviation a little bit. Okay. Let's look at this. Suppose my goal is to have most of the students pass this class. That is my goal. I want you to pass. Okay. And passing means that you get 70% or higher. I don't know if you remember, but I talked about that in the orientation. And if my goal is to have most of my students pass, if the average score is 74%, am I satisfied? What do you think? If the average score of the students in the class is 75%, am I satisfied? What's your guess? Put in the chat box. Okay. It's a trick question. The answer is you can't know. Because maybe almost everyone got 69% and one person got 100%. And the average would be 74%. Do you see how that works? And then almost everyone didn't pass. That'd be horrible. Okay. Or maybe almost everyone got exactly 7%, 74%. I'm very happy everyone passed. Do you see how that works? So actually, you don't know if all you're given is what the average score is. On the other hand, if the standard deviation is 0.02%, am I satisfied? And that one, now what you say is, well, if I go with standard deviation from 74%, that means I'm between 73.98% and 74.02% is within one standard deviation. And even 5 standard deviations will be 50 standard deviations would be between 73 and 75%. And 50 standard deviations like never happens. So then I'm satisfied for sure. Without knowing the standard deviation, I can't know whether most people passed. Do you see how that works? How important the standard deviation is? Any questions on the idea? Okay, so let me give you kind of the rule of thumb. It's called the empirical rule. And it says if the shape of the distribution is normal, and that is often called bell shape, but in our class, we're going to be using normal. And in fact, let me just do this. Normal distribution. I love Google. It just gives me, I'll just do images and look at the curve. Normal distribution looks like this. It looks like this. It looks like this. So this is a normal distribution. I'll just click on the first one. And you'll notice that you get a bell shaped. Okay, and let me show you something important, how the empirical rule works. If you have a normal distribution, then 68% of all the data will be within one standard deviation of the mean. So if you randomly pick one, there's a 68% chance of being within one standard deviation. There's 95% chance of being within 2 standard deviations of the mean. And there's 99.7% chance of being within 3 standard deviations of the mean. So if you are farther than the 2 standard deviations, so more than 2 standard deviations, all right, SD from the mean, is an outlier. In our class, that's going to be our formal definition. If you want to check to see something's an outlier, then you're going to see how many standard deviations it is from the mean. And if that is more than 2 standard deviations, it's an outlier. If it's more than 3 standard deviations, I'll just copy and paste. If it's more than 3 standard deviations from the mean, we'll call it an extreme outlier. Okay, and that's going to be our definition. There's like kind of 2 definitions people use. Just to keep things simple, we're going to use this one. So you must use this one in the class. Any questions on the definition of an outlier and an extreme outlier? Very, very important for a lot of what we're going to be doing. So make sure you understand it, including the project, by the way. Okay, so then what we want to be able to do is find some charts. Histogram. You've probably seen a histogram before. And I want to do the following. I'm going to show you the other one. And then if I go to here, I'll show you the other calculator. The other calculator will do these things a little better. And let's see, let me find it. That's here. There we go. So the first thing, once you've made this thing, is highlight what's there and hit the backspace, and that'll erase what's there. Then what we're going to do is we're going to type in all the data values. Let's type in the data values you put in. And we have 40. We have 46. We have 43. We had 59. 106. By the way, after typing, I'm hitting enter. And then it goes to the next one. So this is spreadsheets. 25. 22, 18, 20, and 23. Okay. And one of the things this will do is we'll give you the histogram immediately. I'm sure you've seen histograms before, but I want to make sure you understand what they mean. So what this says is that there were 5 friends that lived within between 15 and 34 miles from you, or from the people. There were 3 that lived between 34 and 53. There was 1 that lived between 53 and 72, and 1 that lived between 91 and 110. From this histogram, notice it starts high and it kind of goes down from there. It's not a normal distribution. Normal distributions are symmetric, has high in the middle and goes down from the middle in both sides. When it's not symmetric and it starts high and goes down to the right, we call it skewed right. If it's the opposite, if it was a high on the left and then it was high on the right and went down to the left, we call it skewed left. Any questions on that way of looking at it? If it was just flat, if they were all the same number, then we call it uniform. So a lot of words today, right? That would be uniform. Histograms are really good for showing the shape of the distribution. Okay, another thing you can do is you can do what's called the stem and leaf diagram. If I go to stats, stem and leaf, then this will give me the stem and leaf diagram. This is kind of like a histogram, but instead of bars that are just blue, in this case, it gives all the numbers. So what it does is it makes a T-table, basically. On the left, it gives the tens, and on the right, it gives the 1 digits. So notice we have 18, and this 2 zeros, 2, 3, 5 means it was a 20, a 22, a 23, and a 25. We had a 40, a 43, and a 46. So note with the stem and leaf diagram, you can see every value in the data set, which means that you can actually go back and see the data values. Whereas a histogram, you can't tell me if there were any people that were, say, 21 miles away, because we just know there's 5 between 15 and 34. With the stem and leaf, there was no one at 21. We know we had a 20 and a 22. You can actually go back and see the data values. What do you think the problems, sometimes they call it the cons, of a stem and leaf diagram are? Any thoughts? Stem and leaf diagrams are not always going to work for good presentations and data. Any thoughts on why a stem and leaf may not be a good thing to use in every situation? In this situation, it's pretty good, but maybe not always. Yeah, that's a biggie. Is that if you're giving a presentation to an audience that hasn't taken statistics, don't use a stem and leaf diagram, because most of the people won't even understand how to read it. If you're giving it to an educated audience that's taken statistics and understood it, then stem and leaf works well. Let me give you another problem with stem and leaf. Let's suppose we, instead of surveyed 10 friends, let's say we surveyed 1 million friends. There's no way you could do this, because you'd have to put 1 million numbers on this thing. It wouldn't fit. Does that make sense? So if your data set is really, really big, the stem and leaf won't work. And if your audience doesn't really understand statistics, it won't work either. Okay, another diagram or another plot that we often use is called the box plot. Let me click that. And there's the box plot. This is often thought of as a 5-number summary because it gives a picture of 5 important statistics. Do you remember what the 106 was? In our data set, what was that? Yeah, it was the farthest away, but more important, it was the maximum. And the 18 was the minimum. This 32.50, that was the median. And 22.25 and 45.25 were the Q1 and Q3. So it gives you the 5-number summary in a picture. And this is called a box plot. Sometimes you'll see it horizontal instead of vertical. And just however you feel, you'll see it both ways. One of the nice things about the box plot is you can immediately see that the middle 50% are somewhere between 22.25 miles and 45.25 miles away. Do you see how that works? Okay, box plot has the same issue as the stem and leaf plot in that people who haven't had statistics don't know how to read this. Okay, it also doesn't really do a good job showing the shape of the distribution. It's kind of hard to tell. But the main feature is this middle 50%. It does that well, and the max and the min. Any questions on the box plot? Any questions on that? Okay, just a note on the project, you're going to have to do all 3 of the ones I just showed you. That's why I'm spending time on these 3. There are other charts too, like pie chart, and there's a whole lot of others, but these are the kind of 3 I'm going to focus on. Sound good? Any questions on how those are read? Okay, I do want to give you a heads up, is that when you do this on your computer, it may give you a big warning. You may get a virus, and this is dangerous. I will promise you, I did not put any viruses on my spreadsheet program. It will not destroy your computer, I promise. I'm not that, I don't do that. Okay, so, but your computer might block it. And then that's why I have these other links in case you need to see it outside of this spreadsheet, because there's other ways of getting it. And I have links to kind of common ways. You can go out and Google and find it too. Any questions on this? And notice the spreadsheet shows you all the stuff too: minimum, mean, sample variance, sample standard deviation, median, maximum, Q3, and don't worry, SNL left. That means that that's a stem and leaf was a 10th digit. Q1, do we want to include outliers or not? And you can choose yes or no. So if you have yes, in this case, or no, I don't think there are any outliers, but you can do that and redo the box plot. And then now it won't include outliers. So let's see if it were any. We'll find out in a minute. I think there was actually. I think 105 might have been an outlier. Yeah, we did have an outlier. Okay, so notice sometimes you get rid of the outlier so that it's not like all messed up with one big long line. And that would be a reason to get rid of the outliers. Okay, confidence interval we'll do later in this class, and H1 that's later too. Don't worry about that. Z-score. So let's say you want to find out the Z-score of the maximum. The maximum you can see was 106. So see where it says change this? This number 2 has no relevance to what we're looking at. You need to change it to 106, to something that's interesting. And then the Z-score is 2.45. That's an outlier because that's bigger than 2. Do you see how that works? Any questions on that? Okay. And there's a whole bunch of other stuff, a lot of stuff. If we don't talk about in this class, then you don't have to put in your project, by the way. Some of this stuff was done because people from other colleges asked me to put it in. I put it at the bottom, so don't worry about it. Okay, Z-score is important though. Okay, any questions at all on any of this so far? Okay, let's go back to this. All right, so now I have a health question kind of thing. Okay, suppose you are in a hospital. And let's suppose you are going to be doing medical stuff and you're going to be taking care of an infant. Okay, the infant was just born and the z-score of the infant in weight is negative 3.7. What will happen to the child? Any guess? If the z-score of that child in weight, so child's weight, was negative 3.7, what's going to happen to the child? Any thoughts? Give me a moment. Don't see it chopping in. Okay, so the z-score is negative 3.7. So there's two things. One, it's negative. Negative means it's on the low side, right? If the z-score is negative, it's on the low side. It's 3.7 standard deviations below the mean. Remember, if it's 2 standard deviations below the mean, then it's an outlier. If it's 3 standard deviations below the mean, it's an extreme outlier. That means it's an extremely low weight child. If an infant is born that's extremely low weight, you are putting that child in ICU and doing all kinds of medical help for that child. Do you see how that works? Because that child's got issues. Okay, you do not want a child with a z-score in weight of negative 3.7. Okay, any questions on that? Okay, if a different infant had a z-score of 3.1, what do you think will happen? Now it's positive 3.1, note. Any ideas? Okay, so 3.1, yeah, it's more positive. It's not lower end. No, above 3 means extreme outlier. Remember that? It's on the very high end if the z-score is 3.1. Do you see how that works? Because it's more than 3 standard deviations above the mean. This is a giant, huge baby. So what will happen? The baby's probably fine. Big babies are healthy, by the way. But the mother, giving birth to a giant baby is not a healthy thing. That mother's going to get a C-section. Does that make sense? This is how they can use things like this, to find out. Okay, what if a third infant was born with a z-score of negative 0.19? Any ideas? Yeah, it's negative, but actually it's really close to 0. Right? Remember, an outlier means negative below -2. This isn't even close to -1. So that means this baby is just very, very like the average baby, very close to the average baby. Do you see that? So that baby is going to be just a typical baby. Hey, mother's going to get, it hurts when you give birth, but they're not. You don't need any kind of giant care just based on the weight. Does that make sense? Because it's very close to the average. All right, secret word. Okay, we're within 15 minutes of hour and a half, which is that's what I always hope to do. Sometimes I miss by a little bit, and the secret word is bias, because that was really important in statistics. And in chapter 1, you really want to do what you can to not have bias. Now, for your secret word, you got to have bias, because bias is a secret word. So hopefully that's an easy one, nice and short. And just to note, few notes, and that is next week's webinar. It will be Monday at 6 p.m. It'll be on chapter 3. So that's just a note. And we'll be talking about the project and also chapter 3. So kind of important stuff. Just single chapter, but the project. I want to let you know some symbols. This guy is called X bar, and that's the sample mean. And I want to give you a heads up. Very hard to type on a computer, X with a bar on top. Not impossible. I know how to do it, but that might be a tough one. This one, remember, is mu, the population mean. S is the sample standard deviation. And sigma is the population standard deviation. So it's important to have the symbols down because we're going to be using them a lot in this class. These are like the four biggies. And N I didn't write because N's so easy. N is just a sample size. So just some important stuff. So that's pretty much it. Hopefully this helped out. And don't forget, there's a secret word quiz. And you also have the chapter 1 and chapter 2. And you have a bunch of stuff to do. So make sure you go to the week 1 module and do all the assignments. So I think I'm going to stop the recording.